Hello and welcome to video 8 of my Nintendo Wii game programming tutorials. So in this video I will show you how I made the Doh Nut Collector minigame. And the aim of this game is to show off the third person camera and basically to show you what you can do with everything I've covered so far. So in this video I will cover the third person camera. I'll then cover how the level was designed using two different images, and then I'll go over some minor code changes that was needed to assist with the creation of this minigame. As a side note, I will upload the game itself, so you can download it from my itch page if you like, so that the game in its completed state, so you can play it on a Dolphin or transfer it onto a real Wii and play it that way. Also, you can if you like the game and you want me to extend it further, you can donate something and then let me know any improvements or additions you'd like me to make, and I'll think about doing that. So let's have a look at the game first. So I might have to alter the volume here. I think that'll be okay. Okay, so you can use any of the controllers on the Wii. I've tested it with the Wiimote and it plays fine with the D-pad, and I've also tested it with the Classic and the GameCube controller as well, and they all work fine. So if we jump into the game here, you see a mini map at the bottom here. All of the pink there represents donuts on the mini map, and then you can drive Homer around, collect the donuts, avoid the bullet bobs, and navigate the streets to collect all of the donuts. Note as you go around, the mini map is cleared here. The white tile here is you, the driver. The reds are the bullet bills as they move around. The Gumbas and Shy Guys are from the previous video. They're basically just here for NPCs and target practice. So there are 5 levels which I've done here. I'll show you Homer getting obliterated here. So you can also change the third person camera as well. In fact, I don't think I have the buttons configured on here to show you. But if you are using the nunchuck, then you can use the C and Z buttons to zoom in and out. And on the Classic, you can use the left and right, I think L1 and R1, and left and right on the GameCube controller to zoom in and out the camera. So let's talk about how the camera works now. So there's 3 main things we need for the camera. Basically, we need a distance above the target for the camera. We need a distance behind the camera, and then we need a distance in front of the camera. So what happens is the camera is behind the target, but it's not directly looking at the target. It's looking in front of the target, so we can kind of see what it is the target is moving towards or even looking at. The distance behind is always a positive number, the distance in front is a negative number, and the distance above is a positive number. And we also have to pass in the yaw value of the target as well. So we know what angle to rotate the camera on the y-axis as it tails behind the target. I have a function for all of this anyway, so it's all sort of handled. And I've not actually, in the source code, I've not actually put any caps on how far you can kind of zoom away. And then I noticed while testing the game out yesterday that you can almost zoom out above the actual driver, so it almost feels like a kind of 2D-ish game from above. You can kind of get the camera moving towards. So let's have a look now at the models in the game. So the driver here, this is the car is actually based on a Homer model from I think it was on the GameCube, Road Rage. The car itself isn't the actual car. The only thing I sort of took from it is Homer here and the steering wheel. The reason for that is the model itself. If I just go on to Homer a minute. Move this out there. This is the only sort of bits that I sort of took. As the model I downloaded, it had like loads of straggly sort of parts and was difficult to work with. I kept finding there was like additional parts of the model all over the place, so it was easier just to delete everything and just keep the core part and then make the car myself here, which is fairly simple. There is two sort of iterations to it here. There's one where I have created like better wheels here, and I also added like a bottom to the car. As the previous version, this one here, I was cheating and had like a solid cylinder here for the wheels. But I found that when Homer exploded and I sort of threw the car up into the air, it kind of didn't look that great with the large chunky cylinder wheels here. I think also one of the faces here wasn't right. If I look at the face orientation, yeah, here we go. So this face here, the normal is in the wrong direction here. So this wasn't actually drawn as the car was rotating in the air, because this normal is facing the opposite direction. It only displayed here, so from this angle, not from this angle, so it was kind of invisible. So that's why this one is in place here. And then also the note here as well is, if we look directly from above, is to see where the orientation is here. And this is because we obviously need to rotate the car on the y-axis here, so we kind of need it to be able to turn around nicely. And then some other characters here. We have a custom bullet character here. So I created the texture myself here. This is I I think that the eye I managed to get from another image and kind of blend it into this texture here. He kind of almost looks like he's been eating something here, and he's got kind of like blood dripping from his mouth, which is a nice look here. And then there's also this model in here as well. Initially I sort of had the explosion, an explosion dome happen when you hit Bullet Bill, but it was kind of the wrong place. Initially the explosion was happening with Bullet Bill, but obviously at the same time the camera was inside here, pointing up at Homer as his car flew into the air. So it kind of it was obstructing the view, so I removed the code for that in the end. And then we have some different house models here, and I've been playing around with these. Initially these were the ones I was using, but then as the game developed, which I always find when you sort of develop one of these projects, they almost take a life of their own at a certain state, where it's a case of, well, it feels like the game needs to have a more Simpsons theme to it. So I then had a look around the web to try and find some pictures of Springfield to try and figure out what to kind of have the houses look like. And then I finally settled on this in the end. And the reason why so if we zoom into this a moment, I'll talk about what's going on here. So the UVs are actually scaled by 2 on the on this house here. So there's 2 different versions of the same house. There's an X version and a Y version, and that will bring us on to the levels themselves, which I will talk about in a moment. And the reason for this is I scaled these UVs by 2 because inside the code itself, rather than have to keep creating different texture scaled versions of the house for the streets themselves, I just implemented a function to build the house, and then you can just pass in the UV scales that you want, and then it will construct the model and find where the UV scale by 2 is in the original mesh, and then it will scale it by the new values you pass in. So you can basically use the same base mesh, so you can use this house and then create new models from it with scaled UVs however many times you want. It's also useful for you could create like different floors with different UV scales on it as well, basically to enable like more detail via texture wrapping rather than creating more polygons to create the detail. And then we also have our floor here, which is obviously not very exciting. It's just a single plane here. Nothing special there. And then there's also a sprite here. This is a sprite from above. I was initially using this as a debugging aid for collisions. So what I was doing, if I hide that one there, is you see that the this one here, its orientation is in the center there. And what I would do is I would use this sprite here, drop it over the top of the player And then one of the textures I have in here is a bounding box texture here. So all this is used for is basically for trying to figure out, you can basically texture this over a cube or a plane, and then you basically see like a transparent bounding shape around your model, so you can basically tweak the size of this model using this texture, so that you can work out how big a collision rectangle, in this case, or a collision cube should be to fit nicely around your actor in the game for collisions. So this isn't, you won't actually see it used in the actual game, but it was actually used to help me figure out the correct sizes of a bounding shape to go around the player's car for colliding with walls, etc. And then we have a sprite which was used for the donuts in the game. You see that the orientation is at the bottom center here. The floor, not this one, sorry. You'll see the floor, its orientation is at the bottom left here, which is the same as the houses. And this is the reason why I put these at the bottom left, is just for convenience when I align them to tiles. So this, in fact, the only other models to show are the walls which feature in the game. Again, there's an X and a Y wall, and this, if I just show you these. So this is the texture it's using here. As this is an X wall, this face here is scaled by 2. So to be able to use the scaling function to increase the amount of detail on a model, you need to make sure that the UVs are scaled by 2 on the particular like face that you wish to increase the detail on in game. And then there's the Y one as well, which the reason why there's 2 of these is because the this Y one here is a vertical wall, and it's all to do with which face points inside of the map, if you like. So I'll show you the images of the levels here now. It will sort of make some sense to you here. So this is the actual level here, and if I bring up a key from the level manager here, scroll down here a minute, so side by side these a moment. So each of these tiles here just change the color of this a moment so you can see where I'm pointing here. So each of these colors here represents on this this map here is basically the background map or background layer. So each of these pixel colors here represents where a object type should actually start on the level. The cyan color here, this is just a spacer indicator. Basically, this is because these objects here, so for example the first one here is the wall across, so this wall here actually extends across the full width of the level here. But as we are only interested in this, the pixels here basically indicate the starting position of each model on the actual level. So we only want to include the starting position once, but then we add these colors in here, this spacer here, just to indicate that a model is actually extending over that area. So this horizontal wall basically extends the full width of the map here, and you see it's also down here as well. So the horizontal walls basically cover the top and the bottom going across the level. And if I come back in here to that actual model here, so because of the limits in the model format, as I've said before, you can only have a maximum of 7 of anything basically. So to scale this up to 17, which is what I want to do, I basically added a new function to take in the UVs as it's building the object, and then replace that with whatever value you pass in, which in this case is 17, to basically enable that wall here to fill this whole area here. And then the dark red one there represents the vertical walls here. So this basically will create a boundary around the whole level, so you can see where you're sort of confined to, if you like. So you can think of it as like a town perimeter. Sorry. The white one here indicates the starting position here. So the players start, and the walls and houses are on this map here. So it acts as two things. It acts as an aid for building the level, and it also acts as a collision map as well. And then using this, we also create like a collection map as well, as anywhere there's a sort of a space, so a black pixel here, when we're sort of building the map, we will replace, or wherever we find this empty one here within the level area, that's where we will also look to add a donut in the game as well. So these magenta or purple coloured ones here, they represent the X houses, so the houses that go across. And again, what we're actually doing here, so this is the first one is 6, and that's because this goes across 6 pixels here, which translates in the world to 6 houses or 6 tiles. So wherever this object type is found, wherever this pixel is found on here, this will be replaced by a row of houses basically, which goes across here. And rather than build some separate models in Blender to do this, I instead use the function to I'll show you the function here. So it's literally a second build function here, basically. So you pass in the vertices and the indices as we have done previously, except all you do now is you pass in some UV values as floats. So this means you can basically scale, or rather change the texture mapping to whatever you want now. And then all what happens in the code here is when it converts, so this is obviously where it converts the fixed 16 data type into the UV X, or the U and the V, or the S and the T, however you want to sort of describe the texture mapping details. If it finds the value 2, then it will replace this UX value here with the scale value you pass in here. And then same with the Y scale here. If that's 2, then it will scale that by 2 as well. The reason why we sort of had to do 2 models here is because otherwise you would have to have the orientation in the center of the block, and then you'd have to rotate it to face in the sort of correct direction here. So the this face here is the one which will be scaled by 17. You notice that the Y, or the Y UV scale here is still 1, as obviously we don't want to scale that in this instance. So if I come back to this now, I'll come back to the level manager again, and I'll talk through the rest of them here. So we have 6 houses going across here, and then we have 4 houses here, and then the final one here is 5 houses, and these are all the house types that go across. As the this level here is 17 by 17. So the reason why I'm describing this is obviously you might want to make levels a different size. So to be able to do that, you obviously need to know how this actually works. And obviously initially looking at it from the outside, it obviously looks more complicated than it actually is. And then the red pixel colours here represent the vertical rows of houses here. So you'll see that there's a 5, a 3 and a 1. So there's your 5, there's your 3, and these are the odd ones here. And this is the map for the houses and the walls. So the next map, which basically fits over the top of the other one. So you can think of these as like layers, if you like. So this one here is a spawn map. Obviously we're not interested in the different wall types on this map here. And the reason why this is a separate map is because obviously it is purely for starting positions for the bullet bills. For reference, I put the walls in here and also the player start, but that doesn't need to be in here. The player start could also be strictly put in here rather than in here. So you'll see there's a number of different bullet bills here, and the reason for the different colours is they indicate when they should be spawned, as we are reusing the current level. So if I bring this one over here, and then we look at our bullet manager here. So basically in level 1 we will have this one here, and I believe, wait, there, it's in here. Here we go. So the spawn IDs here. So these basically indicate different spawning positions for different bullet characters. So this is for as the levels progress, more and more bullets will actually spawn, which you will need to avoid. Obviously, we don't want them all to be active in the first level. So the spawn lists here. The first number is how many are in the list, and then the second and then the other numbers basically indicate which ID to basically get. So these IDs here start at 1 and then go across here. So you'll see here in the first level we have this one here and this one here. So there's like a free area here that you can sort of navigate around without having to worry about the bullets being here. And then each subsequent level, an additional one will spawn. So level 2, you'll have this one, and this one. And then level 3 will have all 4 of these. And then level 4 will have all of these. And then I believe in level 5 I increased the speed. No, I don't think I did actually. No, I didn't bother with that. Anyway, this is how I sort of planned the level here. So you can use this sort of idea here for if you wanted to have different things at different heights, then you could have like another slice of the same level, maybe at a different height or something. Just an idea for you. This basically just enables you to simply create levels without having to use like a complicated level designer. And then on the flip side of this, you can obviously use my DS to tile converter to convert this into a byte map, which is all I've done here for the levels. You see here, this is the this level here is the main level, and this is obviously the spawn map. So that's the third person camera and the level. So let's go over some minor changes now. So the baddie manager from the previous video has now become the NPC manager, and I removed the cow and the monkey as I kind of want to try and keep the assets down in the demos. Otherwise we end up with like a large file for you to download the source code from, as it's always the game assets that take up the most room, whether that's sound or graphics. Normally sound, actually. It's normally sound. So in this project, there are loads of different sound effects. As you'll find out if you play the game, there's a number of hit sounds for if you hit the NPCs, which are just called randos, because they're kind of like random. They randomly spawn on the level, and then they use the same code they had in the previous demo, where they choose like a random direction and bimble around. Only difference this time is we have some collision code which the player reads. So if we come in here, so there's also a state that is added in here now. They have states, and the reason for that is there is like a die-in state for them, where if you hit them they fly off. And this is a new function here which I've added to do that. So you basically use the NPC run over function here to give you a yes or a no here, and then you pass in the car's angle that you're driving at and your speed, and those have an effect on the direction they get smashed into the air at, and also how fast they rotate on the x-axis, which is the pitch angle. So if we jump in here, so they have a state to them. Where are we? Covered the display list manager. Nope, that's the bullet manager. There we go. So one thing I've found is creating like an enumeration list of actor states. It's always best to have dead as 0. And then I find having like a die-in state as 1 is also good, because then you know anything above 1 is them usually behaving in their normal way. So if I come in here, so when we initialize them, first off we basically set them all to be inactive here, and then set their pitch and their yaw to 0. Some of this is obviously from the previous video, so I won't go into that here. All I'm interested here is the die-in function here. So you can see how that works, and also the update function here, as we now check what state they're in, and then if they are in the die-in state here, then we call that state. And then what this does here is it moves them off on your target value, which is the player's speed. And then what it also does here, this here rotates the X angle basically. So you see we've got like a pitch value in here. This gets updated with this here. So these values here, they are basically passed in via the run over function here. So you pass in the speed and the yaw and the player's collision rectangle here, and then what we first do is we iterate over our NPC list. Make sure that they are alive first and that their state is greater than dying. Otherwise you can hit them a number of different times and they'll just continue to sort of start the dying routine over and over again. So this is why you need to do that. And then we then check to see whether they've collided. If they have, then we play like a bounce sound effect, and then we update that. And then there's a function here, NPCs kill, and then we pass in which one it is, and then we pass the player's yaw and the speed to that function. And then what this does here is it checks to see which type they are, using their texture to do so, and then it will play like a sound effect of that type. It will then set their state to dying. The target yaw will then become the player's yaw. We set their pitch to 0. Their move speed then becomes the speed of the player. One thing I did find out is that if you collide with them and you're not driving, then that can sort of cause a bug here, because obviously your speed is 0. So I have it that they always have a speed associated to the collision here. And then there's a step count value here. So this is how many times the dying function will be called, which will obviously move them and rotate them. So I just kind of come up with, just plucked a value out of the air basically. So this here is how many times the dying function will be called for this NPC here. So in the update function here, you'll see we move the NPC off in the yaw direction at the new move speed now, which is obviously dependent on the collision. We then rotate them on the x-axis here, the pitch, and then what we're also doing here is we're incrementing their y position by their move speed, basically divided by 2. So that gives us the effect of them being spun into the air. That's how that works. And then we basically continue this state here until the step count is greater than the NPC dead distance. Once that happens, we then set them alive to false and take the 1 away from the NPC count. Although it doesn't, recording the number of the NPCs doesn't actually matter for this anymore really. And then what we should do here should set that to dead here, although it doesn't really matter because we are going off of both of these here basically. As you'll see here, it won't even get in here in the update function here if they're not alive. We have to iterate over the whole list because obviously any of the NPCs could die in that list, say in the center of it. So we have to iterate over the whole list every time here. So that's a small change in the NPC manager here. That's how the dying action occurs here. So let's see, what else have I done? Oh yeah, the heads up display. The mini map, that was I was trying to not add one in, but then when I sort of had the game finally sort of playing, it felt like one was actually needed, because you couldn't know for sure whether around the next corner was one of the bullet bills just about to get you. So the mini map was added in here. There was a number of ways I could have done this. The way I chose to do it was to create an image which is drawn on in real time. So I'll go over that now. One of the sort of problems with the Wii is obviously the display looks better at 640 by 480, but obviously that full display is obviously blurred on a TV, as the era that it kind of ran on didn't quite have the digital TVs of today. So the main sort of output was via one of the like analog connectors. As a result, the display is soft, as in it's not fully pixelated. So as a result, you don't sort of the mini map is blurred. Not a lot you can really do about that. There is like a function you can sort of add on to turn off the anti-aliasing, but obviously that will affect the 3D as well as the 2D. So I didn't want to do that. So what I did was I added some additional functions to the image manager here. One of them is create new image, and then there is a pixel set function, a pixel fill function, and this function, which I didn't actually end up using in the end. And then what this allows you to do is you can create like a blank image, basically. One thing to note is, just like the sizes of the textures that you load, the width always has to be a power of 2. Otherwise, internally it creates it as a power of 2. And then that will basically, if you don't take that into account, then you'll end up with an image not as you expect it to be, basically. Hence the image here, the levels are obviously 17 by 17, but I have to create the mini map to be 32 pixels wide, so that I can obviously write 17 pixels across. So this basically behind the scenes, there is a function grrlib create empty texture. So you can do real-time texture manipulation. However, the internal image format is weird. The way that the pixels are laid out isn't, in my mind, isn't a nice way. So if you've ever done any pixel manipulation on any 32-bit images on the desktop, or if you've played around doing pixel manipulation on the DS or the N64, it's straightforward, the formats. Whereas just like the 3DS and its weird image formats, as in the way that the images are laid out internally, the Wii seems to have a weird way of doing that as well. Although the you can get at the pointer, but it's not laid out internally as you'd expect, which is why you have to use the grrlib set pixel to texture image function internally, as this function here uses this nasty formula here to basically work out where things need to be put, as the image itself internally, its layout is really weird. So you see here, this takes the byte pointer of the image data. So this is basically the pixel data. And then it has to play around with it here. And then it kind of has to split things here to try and put them into their correct positions. You see there's like some weird offsets in here, just to overcomplicate things. So I kind of think that the real-time pixel manipulation is actually going to be quite slow if you have to sort of try and update like a large textures pixels. So what I was planning to do initially was to just pass in this function here, was to just pass a whole map as a load of pixel colors, and then initially I was just going to write directly to the pointer in the texture, but that didn't have the effects which I expected it to. I don't think I actually used this function. I'll just double check. Okay, I did use it in the end. I'll go over this in a moment. Okay, so I am actually using this here to directly draw this. Wait a minute, why am I doing that then? Oh no. This is a separate function here. I'm not using this one here at all. So once you've drawn loads of pixels to a texture or an image, once you've done that, you're going to then need to set the handle. Although I don't know whether you need to set the handle or not. I just saw this in one of the some of the source code from grrlib. Initially I tried doing stuff without updating the image. The image looked fine in the Dolphin emulator, but when you actually run it on the real machine, if you do not call the flush function here, I'm guessing that some of these textures must get locked and unlocked internally. So the flush command basically forces the texture's data to be recopied across into video RAM or something. So if you do draw to an image, then make sure once you've finished doing that, you call the image update here at the end of it. So that's kind of how I did the minimap. So I thought I would cover that here. There is like a function here which you can use to draw pixels to a texture. This also made me add an additional boolean in the image type here, whereas is it a pixmap? So if you load something in, there shouldn't be any need for you really to sort of update the pixels on there. Maybe you want to do that. If so, then remove this possibly and change these checks in here. So those are two additional image commands here, and then inside here there are two mini maps here, and then in the level manager there are some colors associated with the mini map in the RGBA style here. So these are 32-bit numbers here in hexadecimal, and then we have the R byte here, there's G, there's B, and there's A. So the background here is basically a dark grey colour which has 32 red, green and blue. That's the background colour there. I kind of felt that I needed to give like a solid colour to the minimap so that you can see it's there. Although obviously it still appears to be a bit blurry, as the image itself is actually scaled. A better way to sort of do it might have been to create like mini tiles and then draw them separately. But the reason why I chose to do an image rather than draw tiles separately is because you're just updating pixels, and then this image itself is actually scaled. So I'll jump into the game here a moment. And then I come into the update heads up display here. There is, I'll close these now. This is the function to draw that mini-map here, and you'll see that I've scaled it 5 by 5 here. So this is a new function I've added into Scene 2D here, which allows you to draw an image scaled. And in this case it's 5 by 5. I'm not sure if it would have been less blurry if I'd drawn 17 by 17 individual tiles to create the minimap or not. I think it might have been better. Maybe the version of this game I upload to itch, I'll do that in. So I think that's pretty much it. I don't think there's anything else I really sort of need to cover. Everything else is pretty much the same sort of stuff from the 2D game, as in the layout of the game itself here. We have the game states here, substates, and the messages here. And then these defines here, these are game dependent. Obviously different games have different things you need to display to the player, so they will always alter. You kind of can't have the same thing all the time. The game itself though, these states pretty much the same for everything really, so I really do not change those. And then if you look in the game itself here, at the bottom is the run function here and the initialize function here. So you see these are all of the game states connected to functions. Which are, the core here is the same as the 2D scroller game. So there's nothing really different to sort of cover here. There is a scene function here. And this is basically the same for every state. This kind of needs to be done here, as we obviously always need to draw everything each update. And this is just drawing the level backdrop. And then in the S3D begin and end is where we draw our objects in the correct order. And then afterwards we draw the heads-up display here, which is obviously the 2D layer which sits above the 3D. So that needs to be drawn last. If you drew this here, then obviously the 3D would be all over the top of it. The only things, I suppose, which are new is the bullet manager stuff here. There's nothing really special in here. The NPC code is more sort of complicated than his, rather than bullets. He has a set direction here. And the reason for his set direction is because he obviously needs to sort of turn really quickly when he sort of gets to the end of a street. So he will he directly basically checks the tile map, and because we don't need to worry about the his rotation to some degree, we can basically set it directly depending on what way he's facing. So you'll see here he's facing up, is yaw is set to 0. If he's facing right, is yaw is set to 90. So on and so forth. So we set his speed directly in here depending on which way he's facing, as he can only be facing one of 4 directions here. So his code is nice and easy. The only sort of things that change each time is his one of the things I did to kind of make the game more interesting, or more random if you like, is the turn direction when he hits a wall. So each start of the level, there's obviously a 50-50 chance that when they hit a wall they will either turn clockwise or anti-clockwise, and obviously that will change the way around the streets that he will obviously patrol. So nothing too special in here. It does have states. The die state isn't really used. It was used initially as I was putting in the dome with a fire texture on it, but then I removed that, as I don't think it needed to sort of be inside Bullet Bill's code. Probably should be separate. Maybe the explosion dome should be after Homer's car falls and hits the floor. I think that's a better place for it. And then there is a to get the spinning effect, or rather the rolling effect that all of them have. They all have like one row value that they all sort of share. And then there is one function here for colliding with them. There is no collision code for the NPCs in Bullet Bill, as it could result in no one to hit for you otherwise. And it would obviously complicate things a lot more, having to have them interact with one another, so I decided not to sort of put any of that in. One of the other things I decided not to do as well was, I think in here, did I start doing it? Yes, I did. So there is a value in here for car health, but I didn't decide to implement that in the end. And the same for I was thinking handbrake turns, but the some of the challenges with the Wii is obviously you're coding on the desktop, so as a result of that you don't have the correct controllers to hand. You can only sort of test the controls out really on the wheel, on the real machine itself, which becomes a sort of pain, as you constantly need to build the code, transfer it onto the real machine, and then obviously check the different controllers. So I didn't sort of develop that any further, as I was having some initial sort of issues with the acceleration values I was using to begin with. In the end, I found these ones to feel better. Obviously, have a play around. Another thing in here as well is the player code is where the third-person camera is set up. So I have not talked about that yet, which is obviously an important thing here. So the structure which holds the details for the camera is the cam ABI structure, which holds values for the above, behind and in front values. Side by side these with the player a moment. So the defaults for these are 24 above, behind, 32 above, and then the in front value should always be minus, because obviously that is looking down the correct Z orientation, which would be in front of the player's car. And then you can obviously zoom in and out. So in the game itself, I have the code. Excuse me. The code to do that. I need more coffee. So to initialize the third-person camera in here, you call the third-person initialize function here, and then what you do is you call the follow target after that, where you just pass in the target's position and it's your value. And then we have the camera follow ABI function in here. Sorry, structure. It has its own inside the camera manager. And then all that happens in here, again, we set up the perspective matrix here as normal. And then all we do is we copy the above, behind and in front to the camera follow ABI structure here, and then we call the camera follow target function directly. and then this is the camera follow target here. And then this uses the sine and cosine here to basically work out the distance behind and in front values. And then it will obviously, using the angles here, it will basically move away from the target at these angles here. So this here basically takes the target's position, and then by times in the distance behind by the sine of the target's yaw on both the x and the z value here. This indicates where behind the target we need to position the camera. So you see the x and z here are passed in the positions here. The camera above function, the struct value of the above is added to the target's y to work out where the camera's y should be positioned. And then the luck value takes the in front x and z values, and then we use the target's y position -1, so we're looking just below its y position here. And after we've set the luck and the position, we then call camera update, which basically sorts out the view matrix as per normal. So that's the third person camera all covered there. Obviously there's probably more ways you could do this. This is just the way I've found to produce recreatable effects, if you like. Keep it simple, I say, like, and then you'll be able to recreate it in your future projects. So the player initialize here, this is where the third person camera is set up using the player's details here. There is some new sound effects functions I've added in. I'm not totally sure how well one of them actually works. I'll quickly cover those here. Nope, not S2D. So there is a play sound effects to function, which changes the frequency. And then there's also a function now which uses one of the A sound functions to play a sound effect continuously on one of the voices. So this is basically how I was creating the car sound. There's like two sound effects which I found. One for like a car idle sound, and another for like an engine ticking over sound. And the idea here was you can use the side by side these again here. Let's get rid of loads of stuff I've already covered. So the one we're after is this one here. So this function here sets like an infinite voice So you need to pass in the ID of the voice, and then this obviously is the sound type. And then you pass in the audio rate. There's a delay value. I'll just put this as 1. You then need to pass across the actual sound data and the size of the sound array data. And then this is the sounds, the volume for each speaker in stereo. So this allows you to basically play a sound effect over and over again. And then there's this other function here which allows you to change the pitch of a currently playing voice. So all of my sound effects here, the default frequency is 48,000. And then I literally just added in a value to that. As if you look here, you'll see that it takes an S32, which is an int. I believe they're the same. I haven't actually checked on the Wii. Maybe it takes a 64-bit number. I don't know. And then also added in one to stop the sound effect as well. Obviously, if we have an infinite voice playing, we'll obviously need to turn that off at some point, and that's what the stop sound effect does here. So this means when you when you're playing around here, you obviously need to keep track of which voice channel you are setting to infinitely play and alter the pitch on. I haven't done too many tests on this, so these values could be wrong, which I'm plugging in here. And then this one here, does kind of the same here. Basically allows you to sort of change the frequency, but obviously this will only play the sound once. Again, I've not really played around enough with these functions to know for sure that I'm actually plugging in the right frequency numbers here. So I think that's it for this video. Let me know if you have any questions about the code. In the next video, I will cover simple animation. So what we'll be doing there is we'll split a model into separate parts, and then we will come up with a system for basically reconnecting those parts. So think of like a Lego man, where you can take the arms off, the head off, the legs off, and obviously you can, because they can come off, you can rotate them separately. So that's what we'll be doing in the next video. I will show you some examples of that. So thanks for watching, and I will catch you in the next video.